Good morning, grade 11s, bright and early on Monday, April 20th. And today I will be posting two videos. Actually, I lied, that's the grade 10s. Today for you, I will be posting this video. It's going to have the key to the practice test and your next set of notes. And I will do the last question from your last set of notes. So let's get going. So your last set of notes, page 95, I left this question blank. So we will work it out now. Remember, that is A, that is B, that is C, and all that equals 0. And you can see this one's a little weird because there's a blank in all of them. But again, it's not that big a deal. We just work it out. We remember that we only care, no real roots, we only care about the discriminant. And if there's no real roots, that has to be less than 0. So b squared is negative 4q squared minus 4 times a, which is q, and then c, which is 5 minus q. And I wrote a there, not q. And then we just do the work, and that has to be less than 0. So that is 16q squared minus 20q plus 4q squared has to be less than 0. 16 squared plus 4, 20q squared minus 20q has to be less than 0. Factor out the 20, 20q, q minus 1 has to be less than 0. So now 20q. Now this is where it gets a little tricky here, right? So either 20q has to be less than 0, so q has to be less than 0, or q minus 1 has to be less than 0. Q has to be less than 1. Now, when you put that on a number line, 0 and 1, both of them, 0 is less than 1, so it's already covered. And q has to be less than 1, so it's already covered right there, all of these. So the only thing we got to check is what would happen right here, right? At, for example, 1/2. And then you would just check it. Okay, so let's wait a second, let you have a look. So now that you've had a look, we can check with 1/2. Excuse me. What's half of 20? 10. What's a half minus 1? Negative 1/2. What's half of 10? Negative 5. Is negative 5 less than 0? Yes. So this works, which means this answer is all of these. Or is it? Let's check here with negative 1. Oops, I should change color. Erase. Negative 1. That would give me, right here, negative 20. Negative 1 minus 1 is negative 2. Negative 20 times negative 2. Hey, wait a minute. It doesn't work over here. So it has to be only the values in here. So q has to be less than 1, but q has to be 0, has to be less than q. And that, ladies and gentlemen, gives me a domain. which you remember from grade 10, domains and ranges. Remember x, if I draw a line like that, -1, 2, -1 had to be less than x, and x had to be less than 2. Right? Okay, let us move on then. Practice test. There is the key to your practice test. This is page 96 and 97, I think. So complete the square. First you divide by 2. That gets me to here. Move the 7 over right there. Half of 10 divided by 2 and square 5. -7 plus 25 is 18. Square root both sides plus or minus 18. Move the 5 over. Quadratic formula. Move the 8 over right there so you have a C. Run it through the quadratic formula. Remember, this is exact. This is approximate. You use your calculator. And remember, you've got to do these brackets for the numerator. Discriminant, you just put it in ABC form. Do the discriminant. Solve by the best method possible. This one's already factored, so you would just do 2x plus 3 has to equal 0, or x minus 4 has to equal 0. Doesn't factor. Yucky, complete the square because it's got a 3 there. So you just use the quadratic formula. No roots, because the discriminant is negative. So there's no solution. Bring that 6 over and factor. Remember, these are the best ways. You could also have done this with the quadratic formula, but you'd have to remember in this one that b equals 0. Bring that over and factor. Bring that over. There. Divide by 3. Now it looks just like completing the square. Square root of both sides, right there and there. And then you've got your answer. And lastly, this one, you just check with the discriminant. You work all the way down to 8/3. You put that on a number line. It has to be less than 8/3, right there. And there's only one value for k that will work. So we check it with 0. 4 minus 36 is less than 0, so that works, so we can go all the way down. All right, let us move on to new stuff, cabbages. Here we are on page 98. Graphs of quadratic functions. Now we already know that quadratic functions have to have that x squared in them. Now, that is the simplest quadratic function. It's the easiest one to work with. So what we're going to do is we're going to work with just that right now. All right? So if I wanted you, so a quadratic function has this form, y equals x squared. If I wanted you to graph this right here, how would you do it? What would you do? Think back to the 9th grade. How would you graph that? Well, most of you would make a table of values or a T-chart, depending on how you call it. Now, which of these do we put in first? We always put in the x's because the x's are our input. Now, I used to do this and I would say, okay, I'm going to use -2, -1, 0, 1, 2. And my students would go, "Oh, Mr. Myers, how did you know what numbers would work there?" And then I would facepalm. Because, of course, these are inputs. I choose them. So right there, I'm saying x is -2. There's an x. What is -2 squared? And the y, I'd say 4. What's -1 squared? 1. What's 0 squared? 0. What's 1 squared? 1. What's 2 squared? 4. And then I would put it on the graph. And that graph would look like this. 0, 0. 1, 1, -1, 1. 2, -2, -2, 4, +2, 4. And you would see a few neat things happen. You would see that when I go that way, 1, I went up 1. I'm going to change shades of green. When I went that way, 2, I went up 4. Now you should see a good little pattern here. Over 1, up 1, over 2, up 4. What is over 3 going to be? I'll wait a second while you think of it. And of course you realize it's going to be 9. And then you notice that right through this line that goes right through the middle, and that middle is the vertex, you will notice that every y value on the right is reflected on the left in exactly the same spot. +1, +1, +4, +4, +9, -9. And it's going to happen that way too. So, from the vertex, remember the vertex is the point where the curve turns back. From the vertex, please highlight all parabolas and I'm going to write this, all basic parabolas. And a basic parabola is y equals x squared. Follow this pattern. And the pattern is very simple. From the vertex. So there's my vertex. They always move that way x and that way x squared, no matter what. Every other parabola is a version of this. Something can happen to this equation that changes this pattern, but in the basic parabola, the parabola that starts every parabola, you move that way x, you move that way x squared. Now, of course, obviously, if we're going that way, it's -x and x squared. So there's a bunch of stuff we got to talk about here. So let's talk about the vertex. We already know the vertex is the point where the graph turns. So I'm going to add a little bit to that. The vertex is the highest or lowest point on the graph. So if it's the highest point, the graph looks like this, right? And then all these points go down from the vertex. If it's the lowest point, then it looks like this. And all these points go up from the vertex. Now, this is called a maximum, because no point is bigger than that. This is called a minimum, because no point is smaller. Now remember, we are working with y equals x squared. So what is the vertex in y equals x squared? Well, we already know because we just graphed it. It goes through the origin. So this vertex is 0, 0. Now the next thing you need to know is the axis of symmetry. That is the vertical line through the vertex. It cuts the parabola in half. So it is always x equals a number, and that number is the x value of the vertex. So in this one, it's x equals what number? 0. That's the axis of symmetry. X-intercepts, we already know what x-intercepts are from grade 10. They're anywhere where x is x and y equals 0. They also have two other names, roots or zeros. And we remember, if this happens in a parabola, then the parabola touches the x-axis. Now you know that the parabola can only touch the x-axis in 3 options. It can touch it never, it can touch it once, or it can touch it twice. Now, let's remember, in y equals x squared, it comes right through here. How many times does it hit the x-axis? Once. X equals 0. Oh, sorry. There's one root at 0, 0. Now, duh, we know what the x-intercept is. It's x0, so what's the y-intercept? 0, y. And that is when the parabola touches the y-axis, and that can only happen once. And in this case, it is y equals 0. Now, we remember the domain from the 10th grade is the set of possible x values. Now, on a regular parabola, we can always put a number in for x. Any number will go there. So, in math, the domain x is a set of all real numbers. You can always put a number in for x. But in reality, the domain is often restricted. For example, if we were doing a graph of time, we couldn't have negative time. The range is the set of y values. And the y values are always restricted. So in red here, it's all real numbers because we could put any number in for x and square it. The y values, if I have a minimum, every y value has to be, y has to be greater than the vertex y value. Because it looks like this. There's my y value for the vertex. So my range has to be bigger than that. If I have a max, y has to be less than the vertex y value. Because it looks like this. And all these values are less than the vertex. So in this one that we've been working on all the way along, y has to be greater than or equal to 0. All right, now let's put this into practice. Turn the page over. This is called vertex form. We are not going to use a graphing calculator. We've already talked about this. Please notice that in this form, you see the y and you see an x squared. All right? A, P, Q, just move the parabola. So let's start with the easiest one. We've already done this one. We've done it. We've worked the whole last page with it. You know how to do it. Let's graph it. We know we're going to start at 0, 0. And since it's normal, we know we're going to move over 1, up 1, over 2, up 4. And those numbers are going to reflect on the other side through the axis of symmetry. And I get that. I know that's 2, 4. I automatically know that's negative 2, 4. I know that's 1, 1. I automatically know that is negative 1, 1. Right? Easy peasy lemon squeezy. Now, look at this one. If I said graph this, you'd make that your good old T-chart from the 9th grade. And let's use negative 2, negative 1, 0, 1, 2. Negative 2 plus 3 squared is negative 2 plus 3 squared. Negative 2 plus 3 is 1, squared is 1. Negative 1 plus 3 is 2, squared is 4. 0 plus 3 is 3, squared is 9. 1 plus 3 is 4, 4 squared is 16. And 2 plus 3 is 5, 5 squared is 25. Now we've got a bit of a problem here, don't we? Right? Because our vertex, well, when we're at 0, we're up here at 9. We never got our vertex, did we? You'll notice over here, when we did our vertex, when we used negative 2, negative 1, 0, 1, 2, negative 2, 4, 0, or 1, 1, 0, 0, 1, 1, 2, 4. You see, we got these two repeated y's, so we knew we'd hit our vertex. Did we repeat any y's here? We didn't. And you can see we're getting bigger and bigger and bigger from negative 2. So we got to get some of these to repeat. So let's go the other way. Let's go negative 3. Negative 3 plus 3 is 0. 0 squared is 0. Oh, okay, now we're in business. 0 is less than 1. Okay, let's try negative 4. Negative 4 plus 3 is negative 1. Negative 1 squared is positive 1. Oh, there's our repeat. So now we've got it. So we know that when x is negative 3, y is 0. And we are going to go up from there. So once we're here, negative 2 was 1. So we went that way, 1. and up 1. Oh, well, that's normal. That's what we had over here. And then we know that reflects automatically there. So that must be negative 4, 1, which we had right there. And then you can see we just follow the regular pattern. Over 2, up 4. So negative 1, 4. Oh, and I had that right here. And that automatically means over here I've got negative 5, 4. Because I've gone 2 away from negative 3 and up. There's my parabola. Now that, you can see right there, that's P, isn't it? P moves the vertex on the x-axis. Now, it says positive 3 up there, it says negative. We have to remember it moves on the x-axis opposite. So, do we have a P there? Yeah, right there's P. What's the opposite? Now, if P wasn't there, and I'll erase it, like I always do, you guys have seen me do this move, that would graph like that, right through the middle, right? But minus 2, I got to move it opposite. So I got to move it out to plus 2. Now, everything else is normal. So I go that way, 1. What's 1 away from plus 2? It's 3. And I go up 1, x squared. So I'm at 3, 1. And then I automatically know that dot is reflected right over here. Same y value, but it's 1, 1. And then I can graph it. What would the next point be? Well, I'd go over 2 from 2, which would get me to 4, and I would go up a squared for 4. Everybody good? Okay, now let's look at this one. Oops. What have I done? There. Now this, you'll notice, this is a Q. And Q, you'll see, it'll make sense in a sec. If Q's not there, how do I graph that? It goes right through here, doesn't it? So, 0, 0, right? 0 squared is 0, so I've got a vertex at 0. But Q is there. So 0 squared is 0 minus 4. It's down here. So Q moves the vertex on the y-axis. And it's normal. So, since it's negative 4, I'm going to drop down here. This is no longer 0, 0. It's 0, negative 4. But nothing else changes. So I follow the same pattern. I go over 1, up 1. Over x, up x squared. So over 1 is 1. And up 1 is negative 3. And then I know right here is negative 1, negative 3. If I go over 2, I go up 2 squared, which is 4. So that gets me to 2, 0. And then over here, negative 2, 0, and then I can graph it. All right, easy peasy, right? So now let's put it all together. There's P, which moves me right, because it's got to be opposite, moves me right 2, and there's Q, which moves me up 5. So I go right 2, 1, 2, and I go up 1, 2, 3, 4, 5. I'm going to run out of room, so I'm going to make this smaller. 1, 2, and up 1, 2, 3, 4, 5. There's my vertex. Nothing else has changed. It's 2, 5. So I go over 1 to what number? 3. Then I go up 1 squared, which is 1. So that is going to be 3, 6. What does that make this one? 1, 6. If I were to go over 2, I'd go up 4. So 2 over is 4, up 4 is 9. And I would go on that way. You guys try this one. I'll wait a second while you try it. You should be seeing a pattern here. I'm going to help you out with that pattern. -2 gave me a vertex x of +2. +5 gave me a vertex y of 5. So right here, you should automatically be able to see what your vertex is. I'll wait a second. And hopefully you have figured it out. It is -2, +3. So 1, 2, 1, 2, 3, and then over, so my vertex is -2, 3, over 1, up 1, -1, 4. That should automatically give you this point, -3, 4. And we graph. Now, you'll notice here, that is an A value. And that A value equals -1. Now, if we try to graph this, xy, if I use -2, -2 squared is what? +4, but there's a negative in front, so now it's -4. -1 squared is 1, but 1 squared, -1. 0, 0, 2, 2 squared is 4, 2, -4. Oops, I forgot 1. 1, -1, 2, -4. So the graph just turns over. A negative number there flips the graph. It reflects it over the y-axis. I call this a sad parabola because it's down. All right, so let's have a look over here. You should be able to graph this. What do you see there and there? That gives you your vertex. Your vertex is what? -5. Oh, but I got to remember, that's P, so it's opposite. So our vertex is 5, 6. So 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6. There's my vertex. And I notice it's a sad parabola. So I got to go downwards, over 1, down 1, 2, 6, 5. And then, of course, that reflects 4, 5. And I just go downwards. Everybody should be pretty good. Now, now we get to the really weird stuff. What do you see there and there? My A's are weird now. And this is where everybody gets screwed up. All right. So let's talk about it. The easiest thing to do is, of course, to do a table of values first, because it shows you how to do it. X, Y. Now, let's pretend that 2 isn't there. So I'll graph this. If I were to graph this in gray, we'd have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, right? If I graphed it in gray. But there is a 2 there. So -2 squared is 4 times 2 is 8. -1 squared is 1 times 2 is 2. 0 stays the same. 1, 2, 2, 8. What happened to all my y values? They all doubled. So this A has 2 things that are a problem. If A is greater than 0, we have a happy parabola, and A tells us that way is still x, but this stretch is now A times x squared. So if I were to graph this guy, 0, 0, over 1, up 1, that's x squared, but now there's a 2 there. So I go over x and I go up ax squared, which is over 1 and up 2 times 1 squared. So this becomes over 1 up 2. Then over 2 up 2 times 4 is 8. So this is now 1, 2, and this is now 2, 8. And then, of course, over here, negative 2, 8, and negative 1, 2. So A is also a stretch factor. I'm going to say a vertical stretch factor. Now, you're smart kids. Nothing there, nothing there. It's a normal parabola, right? Oh, but Myers, there's a negative 4. Okay, so my normal parabola is going to drop down here to negative 4. 0, negative 4. A half? What are you talking about, a half? Well, when it was 2, we went over 1 and we went up 2 times x squared. So what do you think we do with a half? We would go over x and up. It's still an a times x squared. So now everything's cut in half. So I go over 1 and up, not 1, half of 1. So I don't want to put any fractions on here. That's a pain. So I'm going to go over 2 over 2. Now normally I should go up. I would go up ax squared, right? Well, x squared is 2. A is a half. So that's going to be a half times 4. I go up 2. So I go over 2, I go up 2. So this is now 2, negative 2. And over here is going to be negative 2, 2. And it's going to flatten out. Okay? So that tells us something. If A is greater than or less than 1, it's going to stretch upwards. If A is between negative 1 and positive 1, so it's a fraction, it's going to stretch this way. So you should all be able to graph this in your sleep by just looking at it. What's our vertex? Well, negative 2. Oh, but it's opposite. So our vertex is 2 and 6. So 1, 2, and up 6. So there's my vertex, 2, 6. Oh, it's negative. So since A is less than 0, it's going to be this kind of parabola. So I'm going to go down. Now normally I go over 1 and down 1. But there's an A value of 3. So I'm going to go over 1 and I'm going to go down 3 times 1, which is 3. So my first dot is going to be over here at 3 and down 3. 3, 3. And that is going to be reflected right here at 1, 3. Where's my next dot going to be? Because I want 5 dots. I'm going to go over 2. I normally go down 4, but I got to go down 3 times 4. So over 2, which takes me out to 4, and then down 2 times 3 times 4, right? Because I go over 2, square it, so I'm going to go down 4, but I go down 3 times 4, so I got to go all the way down to negative 6. So that's 4, negative 6, and of course over here is going to be 0, negative 6. And that's what it's going to look like. Now, let's put all of that together. A, the A value, when A is positive, that kind of parabola. When A is negative, that kind of parabola. and A changes the stretch. Normal over x up or down x squared. When there's an A involved, A value, then it's over x and it's up or down A times x squared. P moves the vertex in the opposite direction, which means P equals the vertex x. Opposite P equals the vertex x. And then what's left? Q. Q moves in the opposite direction on the x-axis. Q moves the vertex in the same direction on the y-axis, which means y or Q equals the vertex y. You don't need to worry about the opposite. Okay? So, let's do everything we know with this. There's my A, there's my P, there's my Q. So we know that the vertex opposite P gives me my vertex x. So I see P is 4, so my vertex must be negative 4. Q, regular Q, gives me my vertex y, 4, 1. The axis of symmetry we know is x equals the vertex x value. So in this case, it's x equals negative 4. So I can go over here, negative 1, negative 2, negative 3, negative 4, and 1. There's my vertex, negative 4, 1. And I know that everything will reflect across that vertical line, the axis of symmetry. Now, A is negative, so is this going to go up or down? It's going to go down. It's going to go down. Now, normally, I would go over 1 and down 1, but not today. I'm going to go over 1 and down 3 because it's got an A value. So over 1 is negative 3, and down 3 is negative 2. So negative 3, negative 2, which automatically means over here I get negative 5, negative 2. And I go down. The range. So the range are y values, of course. My y values, is this a maximum or a minimum? That is a maximum. So my y values all have to be lower than that. Y is less than or equal to 1. And then, of course, oh, I just did that. The max or min, y equals 1. At x equals negative 4. Alrighty. So let's have a look at this one, and then we'll graph it. What do you see? Well, I see an A and I see a Q, but I see no P's. So my vertex, since P is 0, my vertex must be 0, negative 11. So 0, negative 11. I'm way down here. 0, negative 11. The equation of the axis of symmetry, x equals 0, because that's the line right through there. The range is a happy or a sad parabola. It's happy, so it must be y is greater than or equal to negative 11. So this must be a minimum. The minimum is y equals negative 11. Now let's graph it. Normally I'd go over 1 and up 1, but I have an a value. So I got to go over 1 and up 4 times 1. So that is 1, negative 7. What does that make this automatically? Negative 1, negative 7. What's my next one? Normally I'd go over 2 and up 4, but I got to go over 2 and up 4 times 4, which is 16. So there's 11 of it, and then 7 more. 2, 7, and then over here automatically negative 2, 7. And there's my parabola. Sorry, I went pretty fast at the end there. I'll leave it there on the screen for you for a second. Alrighty, number 3. What's my vertex? Well, I've got an A, a P, and a Q this time. So I know my vertex is opposite P, 3, and regular Q, 5. So 1, 2, 3, and down 1, 2, or sorry, up 1, 2, 3, 4, 5, right there, 3, 5. Now, the equation of the axis of symmetry, x equals 3, because it's going right through there. The range, is that a happy or a sad parabola? It's a sad parabola, so y must be less than or equal to 5. It's a maximum at y equals 5, and then I graph it. Normally I'd go over 1 and down 1, but I've got an a value, so but it's only 1. So I go over 1, down 1, 4, 4, and then automatically 2, 4. Then I go over 2 and down 4. So here I am at 5, 1. And then over here, I'd be at 1, 1, 1. And I would look like this. And then the last one. And this one is, of course, the hardest one because of the a value. A, P, Q. What's my vertex? Negative 2, negative 5. Negative 2, negative 5. Negative 2, negative 5. X equals negative 2. Happy or a sad parabola? Sad. So y must be less than or equal to negative 5. This is a maximum. Y equals negative 5. And I'm going to go downwards from there. So I'm going to redraw my I don't know why that's not erasing. There we go. Negative 2, negative 5. Now, I've got an a value of a half. So I'm going to go over 1 down, over x down x squared. But it's going to be cut in half. I don't want to deal with fractions. Half of 1 is a half. I don't want to do that. So if I go over 2, I should go down half of 2 squared, which equals 2. So this dot right here is going to be 0, negative 7. What will this dot right here be? I've gone that way 2, negative 4, and down 2, negative 7. And it's going to look like this. Okay? Alrighty then. You guys have, I would like for you to do tonight, page 102 and 103. Now, I didn't give you enough graph paper, so you're going to have to put 2 of these on each graph. right? So 1 and 2 will go here, 3 and 4 will go here, 5 and 6 will go here, and 7 and 8 will go there. That's your homework, page 102 to 103. And the quiz that will go live on the Google Classroom will cover these. The quiz will cover pages 98 to 103. All right. You all have a good day, and we'll see you tomorrow at hopefully one or both of our Hangouts.